Let us start our discussion on L'Hopital rule, infinity by infinity form. Okay, what happens? We initially part is the statement of this theorem. Let f and g are the functions such that if suppose x tends to a, the f of x value goes going to the positive infinity or negative infinity. Similarly, g of x also going to the positive infinity or negative infinity. And one thing, the f and g are continuous in a closed interval and differentiable in open interval where x is greater than a and g dash of x is not equal to 0. Okay. And one more condition they given, the limit of f dash of x divided by g dash of x as x tends to a is equal to a. Whenever they try to they given with these conditions, you have to prove this one. Okay, limit of f of x divided by g of x as x tends to a is equal to a. See, whenever the problem given to find out limit of some ratios, but whenever the ratio, the numerator as x tends to a becomes infinity and the denominator becomes infinity, then you have to go to this because you should the function is differentiable. Okay, in that case near the x, okay, near the x, not maybe may not be differentiable at a, possibility at a, but near the x it should be differentiable. Okay, then in this condition we have to find out, see, uh, why differentiability requires, because then only we can get this value. If dash effect exists, then only if limit of this one can we have to prove, if this is the condition we have to prove this limit is equal to this one. No, therefore whenever if you factor out, if I want to prove this limit of f of x divided by g of x as x tends to a is equal to l, therefore I should take this ratio first. Okay, I should take this ratio f of x divided by g of x. Then I'm going to rewrite this numerator f of x minus adding subtracting minus f of a, and then the numerator, and adding and subtracting g of a in the denominator. You can rewrite this one as if you factor out f of x minus f of a in the numerator and g of x minus g of a in the denominator, what happens? This becomes 1 plus f of a divided by f of x minus f of a whole divided by 1 plus g of a divided by g of x minus g of a. If you factor out this term, what term you are going to factor out is f of x minus f of a in the numerator and g of x minus g of a in the denominator. Now if you apply the limit, why? Because we want limit of this once I got the ratio, but I want the limit of this ratio as x tends to a. Take the limit as x tends to a. See here, as x tends to a, this f of x tends to infinity. Okay, what up, keep in mind f of x minus f of a also tends to infinity. Therefore, f of a is constant divided by infinity. Then what happens? This tends to a 0. This ratio becomes 0 and this ratio becomes 0. According to the Cauchy-Minimaliev theorem, this function is continuous in a closed interval and differentiable in open interval. May not be at a, but is differentiable at near the a. Therefore, there exists some c here such that f of x minus f of a is divided by g of x minus g of a is equal to f dash of c divided by g dash of c. It means that whatever the as x tends to as x tends to a, c tends to a. Whatever if you get the limit of f dash of c divided by g dash of c as we can say that x c tends to a, which is same we can get, because whenever x tends to a, c and x almost equal, because try to understand x is very close to the a, c is also close to the a, therefore x and c almost they are very almost equal. Therefore we can say that the limit of f dash of c divided by g dash of c as x tends to a is equal to limit of f dash of c divided by g dash of c as c tends to a. See here, instead of c, you can, if you put c in the place of cx, we can rewrite finally this limit of f dash of x divided by g dash of x as x tends to a is equal to this one. Finally, we can conclude that this is equal to this, and finally we can get. But the question comes, why this f of a divided by f of x minus f of a tends to a 0? See what happens. As x tends to a, f of x tends to infinity, the numerator is constant and denominator grows without bound. With an example, I clarify. For example, if you take f of x is equal to x square and a is equal to 3 here. If you work out this ratio as what happens tending to a, and how this ratio will going to becomes 0. I will say that, for example, x is equal to what happens here, what we are taking, x tending to somewhat a is equal to 3 here. Okay, a is equal to 3. Then for 3, what happens? Okay, with numerical example, how this constant divided by f of x minus constant as tends to 0, as x tends to a, you know that f of x tends to infinity. Let us take the function f of x is equal to 1 over x. See, x a is equal to 0. As x tends to 0, this x gets very close to the 0, f of x tends to infinity. Now, let fix a constant c is equal to 1, okay, representing c may be a somewhat value between a and x. The x is tending to 0 means point 0.1 tending to a 0 here. Then whatever this f of x is tending to infinity, then the whatever the ratio f of x minus c, f of a here, what we can say that, uh, okay, if you take f of a only, that is again f of a is again infinity. It may be any number. Initially, if you, I want to prove constant divided by infinity minus constant. Okay, let us take for representing c is equal to constant. If you take it, then the denominator tending to infinity as x tends to a, the ratio becomes tending to a 0 here. This is how we can say that constant. The similar example, a is equal to 2 here. As x tends to 2, this ratio becomes tending to infinity. And if you, the constant, I want to prove constant divided by infinity minus infinity, as goes on changes, this value will going to tends to a 0. This is how we can say that as x tends to a, f of x tends to infinity, the ratio becomes infinity. Therefore we can say like that. That is the proof we can say.